Logistic regression. How does it work and what is it? So first of all, logistic regression, right? So logistic regression is what we call a classification algorithm. What is a classification algorithm? What a classification algorithm means is that your outcome, which is y, can be of certain categories. It can be true, it can be false, or if it's something about colors, that can be your colors can be red, green, yellow. So the point is the classification algorithm gives you specific classes or extremely specific outcomes that your function could or that you're trying to predict. And it is not a regression algorithm, although there is a version of logistic regression that serves regression, but by default it is a classification algorithm, wherein the purpose of this specific form of logistic regression is to categorize your outcomes into certain classes and not a range of values. So logistic regression would tell you if something is 0 or 1, or at least the logistic regression classification version would tell you that. But a regression algorithm would tell you if something is 0 or is something 0.1, is something 0.8. This is the kind of outcome you expect in a regression based model, but classification just gives you either 0 or 1. That's all. So that is the purpose of logistic regression. How does it do that? We'll just go over that in a minute. Now, say for example you have a function y that is dependent on two variables, right? So y1 is dependent on x1 and x2. Now the value of y is 0 when my x is say 5 and my x2 is say 10. My value of y is 1 if my x is 10 and my x2 is 20. It is 0 when my x1 is 20 and my x2 is 30. This is my data. Now this can be anything. This can be the IQ and the amount of hours someone has studied, and 0 can be whether or not they've passed or failed the exam. That's not the point. The point is for any arbitrary outcome y, wherein it is of extremely specific classes of outcomes, right? It is 0 or it is 1. It is nothing in between. And this is dependent on x1 and x2. So how do we go about it? So the first step is to assign weights. What does that mean? Okay, the point is the whole purpose of this algorithm or regression is to find the appropriate weights. What is a weight? If our outcome is y, our outcome can be determined using certain amounts of weights that are associated to our inputs. So for some value of x1 and for some value of x2 multiplied by a certain amount of weightage that is associated to these two inputs, we'll get the outcome, right? So for some value of w1 and w2, if I input x1 to be 5 and x2 to be 10, my y should then be 0, right? That is the point of assigning weights. So I assign weights to both of these input variables by w1 and w2, and I arbitrarily assume them to be, let w1 be 0.01, w2 be 0.01. Cool. Now the second step is, we also have to initiate what we call the bias. What is the bias? The bias is just what we call W0, and the point of the bias is to be an independent integer that is a part of your evaluation function that is not dependent on any of these input variables. That helps us prevent any sort of overfit or underfit of the data. That is your bias. So our equation in reality looks a little something more like this, that y is equal to W0, which is a bias, plus W1 x1 plus W2 x2. Cool. With that said, now the next question is, how do we go about this now? So we have assigned W1 and W2. We're also going to do W0. W0 be 0.01. And okay, so the step 1 is to assign weights to be each of these things and the bias. Step 2. What is our step 2? Our step 2 is that after we have assigned the weights, we then have to start finding the values of our objective function. What's an objective function? An objective function is just something that we refer to as the y during the training process. So instead of writing y, we don't write y, we write z. Z is equal to w0 plus w1 into x1 plus w2 into x2. Now that we've done this, all we have to do is, the whole point of logistic regression's classification algorithm is that we first evaluate the objective function z at a specific value of x1 and x2. After that, this is step 1. Step 2, we then find the sigmoid. What is the sigmoid? The sigmoid is this really fancy function that you will see when we're talking about logistic regression. That is p of z is equals to 1 upon 1 plus e to the power minus z. Now the speciality of the sigmoid function is that this value is always in between the range of 0 and 1. Why is that? Well, that is because by design, logistic regression's classification version is best suited to be for binary classification. What is binary classification? Binary classification simply means that your y is restricted to being 0 or 1. It can be true or false. It can be black or white. It can be alive or dead. That's it. It can only be binary classification. Simply means that your outcomes, that you can only have two possible outcomes. Alright, anyway, returning to the sigmoid function. So now that you're at the sigmoid function, we first evaluate the value of z for any two inputs. We then plug that value of z into the sigmoid function. Once we found p of z, we then have to find the error. What is the error? The error is, simply put, the difference between the value of the sigmoid function at some n, like n being, say this is e, this is the first value, this is the second value, this is the third value. So for the first value, this would be n equal to 1. So p of zn minus y of n. So if I were to evaluate it for this specific row of data, so my y here would be 0. So this would be whatever value of z I get for 5 and 10, that minus this. And once I found the error, we sort of just leave the error be, we just take note of the error. Anyways, let's get started. So my first value is 5 comma 10, right? So x1 is 5, x2 is 10. So x1 is 5, x2 is 10. So what was the first step? We evaluate z1 being 0.01 plus 10 into 0.01. 10 is x2, 10 is x2, and 0.01 is the weightage that is assigned to x2, plus 5 into 0.01. This would give me, this is 0.16. Step 2, sigmoid of z1. So that is 1 upon 1 plus e to the power minus 0.16, which is this is 0.53. As I told you, this value would always be between 0 and 1. Anyways, now the third value, that is the error. What is the error? The error at the first value is the value of the sigmoid function, that is 0.53 minus the value of y. What is the value of y? It is 0. This one is 0, which is 0.53. So now what I'm going to do is I'm going to take note of this. I'm going to say that my E1 is 0.53. Now I'm going to do this exact same thing for the other values. So we next have x1 equal to 10 and x2 equal to 20. Okay, yeah, all right. So z2 is 0.01 plus 0.01 into 10 plus 0.01 into 20. That would give me, this would be 0.31. Then my sigmoid of z2 is 1 upon 1 plus e to the power minus 0.31, which is, this would be 0.57. So then I get my error at value number 2 to be the sigmoid, that is 0.57 minus the real value being 1. This is 1, which is minus, oh wait, how much is that? 0.57. 343, right? Okay, so my error is minus 0.43. So I then get error 2 to be minus 0.43. I do the exact same thing for the third value now. What is the third value? It is x1 equal to 20, x2 equal to 30. Same process. It's a little angle now, I think. Oh gee, it is really quite angled. Just work with it, doesn't matter. So z3 is 0.01 plus 0.01 into 20 plus 0.01 into 30. This gives me 0.51. Now my sigmoid at z3. Yeah, anyway, right. So the value of the sigmoid for z3 is then equal to the 1 plus e to the power minus 0.51, that is 0.62. Now the error for the third value then becomes the sigmoid minus the value here, so that's 0. This minus y3, which is 0.62 minus 0, which is 0.62. Okay, so now that we have all the three error values, so that's E3 equals to 0.62. Now comes the part that is the third step. What is the third step? So after we found the errors for all the values, we then move to step 3, that is finding the gradients. How do you find the gradients? In order to find the gradients, all we have to do is simply sum up gradients for of the weight of value n is equals to the summation of error into the value of x. So what does this mean? Okay, I'll just explain. Okay, so for instance, we have the gradient for weight 1. What is weight 1? Weight 1 is the weight that we assigned to x1, this row, right? So the gradient for weight 1 then becomes error multiplied by the value. So for the first value, that is 5, what is the value, what is the error? 0.53. So I do 0.53 into 5 plus, for the second value, that is 10, what is the error? Minus 0.43. So minus 0.43 into 10 plus, what is the third value? 20. What is the third error? 0.62. So 0.62 into 20. This gives me a gradient of 10.75. Now typically gradients are very small numbers, but the reason why we have 10.75 here is because of the disparity of the data and the amount of variance. I mean, you have x going from 5 all the way to 20, you have x going from 10 all the way to 30 in an extremely small range of data. So that is why a lot of the gradients might look off, because they are off, but typically it is a really small number. Anyways, moving on. So like this, we then do the gradients for weights too. Again, what is the process? Error. So my first error is 0.52 into the value here. So the first error into the first value. So 10 into 0.53, essentially the exact same thing. 0.53 into 10 plus minus 0.43 into the second value plus 0.62 into the third value. That is 20 and 30. So 20 and 30. That would give me, this gives me 15.3. And now, so weight 1, weight 2, and now comes the gradient for the bias, it is weight 0. Now for the bias, the way we calculate the gradient is the same thing, but because the bias, like I told you, is independent of these variables, you just multiply it with 1 instead. So what you get is 0.53 into 1 plus minus 0.43 into 1 plus 0.62 into 1. What that gives you is, that gives you 0.72. 0.72. Alright, we found the gradients. Okay. So the gradient for weight 0, which is your bias, is 0.72. Gradient for weight 1 is 10.75. 10.75, and gradients for weight 2 15.3. 15.3. Now that we have all the gradients, the last step of this entire process is step 4, update weights. Keep in mind, the entire point of this entire algorithm is to find the optimal weights for this equation right here. It is to find the optimal amounts of weights in W0, which is your bias, your weight 1 and weight 2, so that when you input in a certain value at x1 and x2, you get the correct z value. So now how do we update weights? Updating weights has a really simple formula. Your new weight is equals to the old weight minus alpha into the gradient. Now what is alpha? Alpha is a constant which is known as the learning rate. What is a learning rate? The learning rate essentially is an extremely small number that quantifies the amount of significance or change that is to be made to the weight. That's all. So if your alpha is really low, your weight change would be really low. If your alpha is really high, your weight change would be too high. So it is typically kept at a really small number, like alpha is equal to 0.0001 01. And anyways, so let's proceed. So my W0 is then equal to 0.01 minus 0.001. What is the gradient for alpha? It is 0.0. So 0.72. Sorry, 72. This would give me. So this then gives me 0.0098. Then if I do the same thing for weight 1, that is the amount of weight assigned to x1, I get 0.01 minus 0.001 into 10.75, which is then equal to minus 0.00075. Weight 2 is then 0.01 minus 0.001 into the gradient here, which is 15.3, which then gives me minus 0.00053. And we repeat. Now you might see that these weights are really small. That is because of a number of factors, mainly being the one that I previously mentioned, being the fact that the data is a little too variant and it has too many outliers. So while the data is at fault here, this entire process is to simply display to you how logistic regression works. Now the question is, once I've updated the weights, is that all? No, it isn't. You have to keep repeating this process of finding the z values, then finding the sigmoid, finding the errors. Once you found the errors, find the gradients. Using these gradients, you update the weights using this formula, and you have to keep repeating this process until again and again until your weights converge. What that means is that your weights start giving you the correct values. And the amount of times you repeat this process, this loop of find z, then you find the sigmoid, then you find the error. After having done all of this, you then find the gradients, you then update weights, and then you repeat this process again. This process has to keep going on and on until your weights start giving you values that are closer to the expected outcome. And the amount of times you have to repeat this loop is what we call the epoch. Now the epoch can vary, but that's all. So this is how logistic regression works. Thank you.